Good evening, everybody. I want to welcome you here this evening. It's a great turnout, and I think we have a really interesting speaker this evening. I'm going to get rolling now, and Mark Riley is the remote sensing specialist for the U.S. Forest Service with the Alaska region. He's been doing that for the last 4 years. He supports the remote sensing program in the Chugach and Tongass National Forests in that role. His background includes service as a U.S. Peace Corps volunteer in Ghana. He has done remote sensing work for agriculture in Colorado. He's modeled vegetation for the Forest Service in California and has done on-site remote sensing support for the United Nations peacekeeping mission in Ethiopia and Eritrea. He earned a bachelor's degree in geography from Aquinas College in Michigan and a Master of Science degree in Remote Sensing and Forest Sciences from Colorado State University. Now, those of you that work at the University of Alaska Southeast would probably identify more with another role that he plays. He's actually the husband of the most important person in the School of Arts and Sciences, Margaret Ray. Yay! Mark has actually also started this year as an adjunct for us teaching remote sensing techniques to our students, and I think some of his students are here. So welcome here, all of you students. I'm going to move on now. His topic is remote sensing of mountain goats in southeast Alaska, and I'm going to ask you that when we get to the point where you can ask questions, please hold your questions so that we can get you the microphone. We're recording this, and if you don't wait for the microphone in the recording, there's this quiet, just silent period that when people watch the videos, they go, "What's going on?" So if you'll wait, we'll get you the microphone, and your question will be forever memorialized. So with that, I'm going to turn it over to Mark, and you could introduce your co-authors as well, okay? Yeah.
Hey, thanks, everybody. And thanks, Pat. I thought he was going to say something funny about me, and I was going to comment that I'm much better at dishing it out than taking it, so I appreciate that. And I'd like to I see a few folks from ENVS 403. Thanks for coming out tonight. And Dennis Chester, Jeff Nichols, and Kevin White are here. And I'd like if you could just throw up a hand. Thanks, is Chad. Chad didn't make it tonight? Thanks. Anyway, this topic, remote sensing of mountain goats in southeast Alaska, and I'm going to go ahead and get started. The mountain goat. Oriomnos americanus is a key indicator species for managed recreation areas. And the population's behavior of goats can be used to predict response of other species ranging in the same habitat. And the last part of that, well, actually this entire sentence was new to me. And thanks to Dennis and Kevin White, explained the importance of monitoring the habitat and doing mountain goat surveys. So standard aerial survey techniques, wildlife biologists and aircraft, limitations due to weather, time of day, time of year, and there are safety concerns. Current techniques require a low altitude, slow flying aircraft and multiple pass visual count by a wildlife biologist. And it can be very cumbersome and time consuming on the ground effort. Field population surveys have safety concerns in southeast Alaska that range from exposure, steep terrain risks, and potential bear threats. And Dennis Chester and Kevin White looking for a new method, trying some new technology, approached me and Jeff Nichols about conducting a study using remote sensing technology to supplement field observations. That is to say, what kind of instrumentation can we use from a greater distance at a higher altitude in an aircraft to try to observe goats in their habitat? And on the ground, goats are really hard to spot, even when close in dense vegetation. This is an image from Kevin. And now I'm going to talk about this collaborative study, the Forest Service and Department of Fish and Game, remote sensing application for wildlife, mountain goats. It was collaborative and implemented concurrent collection, the simultaneous collection of thermal infrared and multispectral, natural color, vertical airborne imagery from an aircraft to survey mountain goats and their habitat. Initially, our objective was to determine the feasibility of using a thermal infrared sensor, a camera that will detect heat emanating from the goats. The project area, chosen because the Alaska Department of Fish and Game was conducting research here that involves mountain goats deployed with GPS collars. The proximity, very close to Juneau International Airport, enabled testing the efficacy and sightability of mountain goats with this multi-sensor technology, a thermal camera and a natural color camera. Very good for reduced costs as compared to working in a separate area at a greater distance away. Mobilization, meeting at the airport, getting to the test site. Very minimal costs due to the geographic nearness. And this area here shows the approximate area of the study site. For reference, Mendenhall Glacier, the Juneau International Airport, and a little north of here is Herbert Glacier. So it's about 8 miles north of the Juneau International Airport. Characteristic terrain, very mountainous, heavy canopy cover at lower elevations, and higher elevations are steeply sloped with less dense herbaceous and shrubby vegetation, rocky outcroppings and snow cover. Due to latitude, right about a little less than 60 degrees, under 60 degrees north, and sun angle, low sun angle, there's often a lot of shadow on north-facing slopes. And at the time of the survey, the goats were in an elevation of about 3,000 to 4,000 feet. The topography, rugged mountainous terrain, a lot of glacier activity, rocky outcroppings, patches of snow, and high meadows. And I'm always kind of amazed at in the right light, the ethereal quality of this landscape, and kind of has a Middle Earth sort of feel to it. And when I look down, I sometimes expect to see a village of hobbits or elves. And I think that comes from reading too much Tolkien when I was younger and had more free time last year. So, this is another image of the terrain, a little closer up, perspectives from the Department of Fish and Game, showing goats in their natural habitat. And the goat here is not making a bold-fashioned statement. That's one of the radio collars that was installed by a wildlife biologist. So, body temperature and ultrasound measurements were taken. And I have this slide up to illustrate the collaring of the goats. This is Kevin White and Karen McCoy taking some measurements. They use an ultrasound device to measure fat on the goat. And in their unconscious condition, they didn't really have much choice where the body temperature readings were taken. So I thought that was... So this prior knowledge of these goats and the work that Fish and Game had done was not critical, but it was really important from a time-saving and a cost-saving standpoint. So we had a good idea of where to go and could fly directly to the study site and spot the goats. And flight planning, really difficult in this climate. Images of Berners Bay and Lena Point from about the same time of the year that me and Jeff Nichols were trying to coordinate to get out. So we needed good sunlight, not only for safety reasons, but also for reflectivity off the landscape and the goats, and actually see the landscape. A couple loosely interpreted categories of weather, typical, and where was I when this happened? This right image. And something I really love about Juneau is the strong oral tradition of the weather. Sunny days or rainy days. And I'm like, oh, summer's terrible. And I was like, you should have been here in 92. It rained. It didn't stop raining. So we got lucky. We got a nice sunny day. There are several webcams throughout Southeast Alaska, and this was one of the primary ones that me and Jeff used. And for about 3 weekends, we would call each other, look at these webcams, because the microclimates in the area, downtown might be different than Douglas and Berners Bay. And this is the area we were interested in. So the Peterson Hill webcam, kind of mounted on this peninsula here, is used by pilots. And so we would look at these images and to see what the weather was looking like. And we got a good day finally. the image on the left, ideal conditions. And we're very close to what we had that day. It was about 70 out, a little bit of cloud cover, but really, really pretty. More often than not, this is that same area. This is what we're presenting with. Not good conditions for remote sensing from an aircraft with cameras. The platform, we use a de Havilland Beaver. Ward Air, really great company to work with. And the image on the left here, you see Dave is the pilot looking at Jeff mounting the camera. There's a hole in the belly of this aircraft that we put the cameras in. They're pointing straight down for imaging. And this took about 1 hour. And as part of safety, we're required to wear vests. And these vests have a CO2 cartridge in it. And they inflate very quickly. And Jeff demonstrated this soon after we got up in the air as he was leaning over the seat to adjust the camera and caught the release. And I heard this, and I looked over and saw this giant thing growing next to me. And after the flight, I asked Jeff what he thought and what happened. And he said he had no idea how big it was going to get. So it made for an interesting flight. Yeah. And the image on the right, the mountain goat habitat, this is a view from the cockpit of the airplane, looking actually east over the Juneau ice field towards Canada. The instrumentation, the next few slides are a little, well, actually from here on out, they're pretty nerdy. But I wanted to talk about the instrumentation. And the next slide, I have a larger picture of that. The image on the right is the view from below the aircraft. You see the two camera lenses and plywood, which is a very low-tech solution. The rim around that is aluminum, but plywood's a great surface. It's easy to shape, and it dampens vibration from the aircraft very, very well. So it's really nicely done. In fact, the system that Alaska Department of Fish and Game put together is really very nice. On the left, we have a power supply, an inverter that connects directly to the aircraft. And it converts a 24-volt output to 110 so we can plug computer equipment into it and the cameras. This here is the actual thermal camera. This device is an inertial measurement unit, and it's mounted jointly with the multispectral camera and the thermal camera, and it records pitch, roll, and yaw of the aircraft. So if the airplane is angled at a certain, if it's yawed or if the nose is down, this will record that. And later on, we have these flat images of the Earth, and we're able to correct for those angular errors in the aircraft. And doing that with an airborne GPS that's recording a latitude and longitude for every image allows us to georeference this imagery, bring it into a GIS, and make very, very good measurements with it and locate it on the Earth. We have here the computer software, and this is a Nikon DCS camera. It is a commercially available off-the-shelf camera. And Fish and Game originally designed this system for fish habitat studies, looking at water temperature. And when we talked to Jeff, we determined that it would be effective potentially for collecting images of goats on the landscape. And I warned you about the nerdy slides. These are details of the two cameras, the thermal sensor and the multispectral sensor. And mostly I put this up to make a note of the resolving power, the resolution. The thermal camera is very coarse compared to the color camera. For example, the 50 millimeter lens at about 820 feet, the thermal camera can actually see spatially on the ground a 25 centimeter object, whereas the color camera can resolve a 4 centimeter object. The footprint disparity, that's the extent of the actual image. At 250 feet, the thermal camera has a much smaller footprint. And there's some trigonometry and math for calculating this. And I kind of got too lazy, and I found it easier to learn a programming language, embed these algorithms and formulas into that. So that's kind of what I use. Here's another one, the electromagnetic spectrum. And I had this only up here for perspective. It's a continuum. And this short notch is where we see its natural color, red, green, and blue. and that's what the color camera sees. This is light that's reflected off objects on the Earth's surface or features on the Earth's surface. It allows us to discriminate colors, shapes, texture, and a little longer wavelength is thermal infrared. And thermal infrared isn't sensing reflected light. It's wavelengths that are emitted from the Earth, whether it's sunlight that's been absorbed and retransmitted or a warm body, a cold body. Those wavelengths are emitted into the atmosphere versus being reflected from sunlight. Here's a good example. All this is, that image you see in the center is a thermal image of this area. And this shows the relative sizes of these footprints. The larger image, the natural color image, the spectral image, the thermal image in the middle. The darker areas are cooler, the lighter areas are warmer. And initially we're like, wow, this is working great. We can see where the snow is, we can see rock, we can see these different landscape features reflecting heat or emitting heat differently. But the pixel size, the 2000B, the thermal sensor had a much, much larger pixel. And a pixel, picture element, this is the actual cell on the camera. If you have a digital camera, it's composed of these that records light. And this is a goat here. And we wanted to make sure we didn't fly so high that spatially we weren't able to resolve a goat on the ground. So we determined a good altitude. And this goat should have been taking up about 6 pixels. And if the thermal camera was sensing them, these pixels should have appeared more white, and it did not. Another image. The right, this is from the color camera. Circled in yellow are 5 goats. It worked really well. The image on the left, the surface feature patterns are clearly differentiated. Snow, rock, ice, grass, herbaceous vegetation, shrubs. We can see those pretty clearly. But the mountain goat, the heat signatures, this is taken at the same time, are completely absorbed by the landscape. So when we looked at this, we're like, well, did we goof up? We didn't. But the multispectral camera worked really well. So when we looked at this image, the pixels on the left with goats in it should have had a lighter color. So we made some initial observations. The goat heat signature, the heat emanating from that creature, was likely to show up on snow or vegetated areas where thermal contrast is greatest. By thermal contrast, that's the heat difference. We thought the goat would have more heat than the background landscape. But instead we saw something called thermal loading. And that is the heat difference between the goat and the landscape, whether it was vegetation, rock, or snow. There wasn't much difference, not enough difference to show up in the thermal part of the electromagnetic spectrum. And also we kind of hypothesized that emitted heat from rocks may contribute to masking the goat heat signature. A heavy fur coat greatly diminishes thermal contrast. In grassy areas, the goat heat signature is absorbed. A goat present on a patch of snow in July or August when the coat is thinnest may offer enough thermal contrast. The temperature between the goat and the landscape might be enough to be able to resolve the thermal sensor. And in addition to their well-insulated properties, this also illustrates very well hydrated as well. I thought that was kind of an interesting picture. So the multispectral camera worked great. We were able to see an individual browsing goat, the legs, the head. We could even tell that it's browsing, eating grass. Clearly resolvable in natural color. Shadow, shape, position in the landscape made for confident image interpretation. There are 18 goats here. There's some here, and you can see them throughout the landscape. This is the visible spectrum, natural color. And this also creates a great record. There's a timestamp. We have a coordinate. And this can supplement field work done by the wildlife biologists tremendously. So they can come back. We counted 18 goats in this area. And they have a verbal record of it. They might even have an image from the aircraft. But with this, and with the inertial measurement unit and GPS, it can be registered and made geographically relevant. And we also thought really interesting just the reflective qualities of the goats in shadow. That's the top image is cloud shadow. Provided even more contrast against the landscape than in full sun. Under these conditions, the goats exhibit even greater spectral contrast with rock and the surrounding vegetation. And we did multiple passes, and in doing that, each image at a time, we were able to tell how far the goats moved, what they were eating over a short time period. And object extraction. Wanted to find a way, how can we get these goats out of that scene very easily? So I used some feature extraction software. It looks for patterns in the landscape, and it did a great job delineating individual goats, but it also did a really good job of finding areas of rock that were in the same shape and a very similar reflectance as the goats. Easy enough to count goat polygons in vegetated slopes. There could be air introduced if goats are traversing rock or snow to access vegetated areas. And we didn't do any image enhancement on these. There's no sharpening. These are raw as we receive them from the camera. Here's a great slide. This explains how object extraction works. This yellow polygon is outlining a goat. Each of these cells has an associated digital number. In this case, it's 255. And this software we use, and there is a lot you can do, but instead of delineating or extracting the shape of that goat, we look for patterns of numbers in the landscape that represent the goat. And where we saw confusion in this earlier picture, these patterns that we see numerically are very similar to those of the goats. Recommendations: thermal infrared imaging techniques may be successful if mountain goats are present in snowpack where thermal contrast is enough for thermal detection. Acquiring imagery with multiple sensors, a thermal and a color camera, will ensure that no goat goes uncounted. Either sensor used individually may not yield a full population count for a study site. Prior knowledge of the range and occurrence will save time and money for airborne imaging. Great interdisciplinary collaboration with the wildlife biologists using different technologies. I wouldn't have known where to look, really. I know their goats are in high elevation areas. It was a wildlife biologist helping direct us where to go and how high to fly so the goats could be imaged. The aircraft we use are a similar aircraft like a Cessna. Great platform. Don't need a pressurized aircraft. Don't really need to go far distances. So that worked out really, really well. Multiple flights with multiple flight lines, overlapping transects should be flown through the spring and into the fall season in order to capture rutting and range variability for a group of mountain goats. Lower elevations, denser shrub and tree vegetation canopy is likely to conceal goats. And we saw that even close up with the camera, or the image of the wildlife biologist at Kevin. Flight should be during times when mountain goats are ranging at higher elevations. We achieved that in subalpine and alpine environments where the vegetation is dense. And the camera we used had a very small imager, a CCD, a charge coupled device. And this is the actual material that collects light and records those images. It had very large pixels, very short focal length. And I think in future work, we're going to try to find a camera with smaller pixels, one that we can fly higher or at the same altitude, but will have a better resolution on the ground. More work is necessary. We really made a lot of progress, but more work is necessary to fully understand thermal contrast, thermal loading of mountain goats in this environment, in the Southeast Alaska habitat. They're so well insulated with fat and fur that thermal contrast may not be sufficient in order to resolve these animals. Multiple flights of goats on snowpack or ice would have resulted in a more conclusive determination of the heat signature using a thermal camera. Airborne image acquisition should include active and resting animals, individuals and herds, and kids as well as adult males. And we did achieve that with this study. The use of image classification, object extraction, feature extraction needs to be explored in a larger capacity. Natural color can split up into different bands of light, blue, green, and red. when I was looking at these individual bands, I noticed a slight difference in the goats in the blue band. It may be too subtle, but we're going to hopefully research that a little more. The thermal eye, the camera that we use, great for the application that it was designed for, fish habitat studies. Not great for mountain goats. We did discover that. That was conclusive. A commercial off-the-shelf camera can effectively resolve mountain goats ranging in southeast Alaska. And it wasn't until the past couple of years that digital cameras met the same resolution qualities spectrally and spatially as film cameras, and they've exceeded it. And this technology is much easier to work with. There's a quicker turnaround time, and analysis is much better. But the goat heat signatures are most likely to show up on snow or vegetated areas where contrast is greatest, thermal loading is lowest, bare earth is warmest. A geolocated image-based data set that's taken that flat vertical image, giving it a coordinate system, using it into a GIS, can create a defensible historic record of a mountain goat population survey. And our working hypothesis after this study is that goats are so well insulated that they're effectively invisible in the thermal infrared spectrum. And while we need to pursue that a little more, it was really nice to discover that with this camera and these specifications. It didn't really work because the goats are so well adapted to their habitat. And while their internal body temperature is about the same as a human, their external body temperature is not. It's very close to the ambient environment. And this, I think, is just a beautiful image that Kevin took. I think it's a nanny and a kid. I'm not sure where this is, but I want to thank Jeff Nichols, Dennis Chester, Kevin White. They were the catalysts for doing this project. They approached me and Jeff. Jeff's been great to work with. Really appreciate it. And I want to, before we end, thank Ginny Mully for inviting me tonight and for organizing the Evening at Egan lecture series.
Thank you.
Thanks.
Thank you. If you have questions now, this would be a good time. We'll get you the mic.
If anybody has a question, Pat, we'll bring the microphone up
Yeah, that's
and hand
right.
it to you. And if not, or a comment, an observation. And if anybody really wants me to go back to the slide of the electromagnetic spectrum, I'd be happy to. Although I think this is a much friendlier image to look at.
I've got one question that I'd like to ask, and that's, are there other species that you've thought about applying this for? I would think it probably would work best in open habitats rather than forested habitats and that sort of thing based on your results. But are there species of plants that might have thermal reflectance that would be, you'd be able to pick it up? Or are there species of waterfowl or other species that this might be useful for?
Yeah, with this thermal camera, you can somehow detect evapotranspiration. The thermal band can be used in conjunction with other bands for evapotranspiration of vegetation, but it's sort of an estimate.
Okay.
And you asked what other species. Jeff and I were talking yesterday. We had referenced a study in California of mountain goats using a thermal camera. And this is where the rock on these mountains is in sun and might get up to 120 degrees. And we're thinking there's no way these goats are operating at 120 degrees, but they're cooler than the surrounding rock. So the thermal camera in that environment was able to capture them pretty effectively because their color in the natural color spectrum in a regular color camera blends in so well. But in that environment, very different than here, much hotter, much drier. It was a more appropriate technology. And if anybody has a specific wildlife question, I will defer that to a wildlife biologist. I'm a remote sensing specialist.
This is not a wildlife question.
Okay.
Would you be able to sense with one of those cameras potential thermal springs or hot springs? We could sure use one around here.
Absolutely.
Could you pick up something like that, or
You would, because the thermal contrast is so vastly different than the land around it that would be detectable. Although with that small footprint of this camera, it would take hundreds of thousands of images, and I don't think Jeff, he's shaking his head right now, so. But that's a great question. Thank you.
Well, I am a wildlife biologist, but I have a non-wildlife question. These have been attempted 3 or 4 or 5 times across the state of Alaska. And
With a thermal camera?
yes, and my question for you is the imaging platform that you use, the camera, the thermal camera, is it higher quality or lower quality than in particular all these companies that approach our Department of Fish and Game and want to put them in fancy aircraft and say they can count mountain goats on the Kenai and grizzly bears all across the state? Because we get approached about once every year or two to do this.
Yeah. The camera was available. It is fairly coarse, and we haven't really looked at other camera systems. We use this because it was available. And we looked at the pixel size to see if it spatially could resolve a goat, and it could. The spectral range, I think, was 7 to 12 micrometers. Maybe going a little bit beyond that, using a finer resolution camera might work for that application. It was a little small. This camera was initially designed for surveillance of humans, like at factories, and Fish and Game did a really wonderful modification and a much less, I think, sinister application for detecting heat of water in fish habitats. But that is an excellent question. That's where we need to do more work.
You know, with your airborne GPS, are you able to quilt the images with each other and index from frame to frame, or is that a software-based?
We can do that in a semi-automated approach. Often the user will have to input control points of features between each image. That is the edge of an ice field on one to the edge of another. And with that GPS point that's collected at the center of the image, once we've stitched or mosaicked several images together, that can be used to geolocate it. And it's hard to do. It works really well in a flat, like the interior where the landscape is flat. But with that steep terrain, we need something called a digital elevation model to correct errors in terrain for those images. If we want to do something called orthorectification, a really robust warping of that image so it fits, not just on the Earth, but on the landscape, the topography better.
Has the remote sensing worked for any mammal up here? The thermal
It
sensing?
has. I know folks are using it for seal counts on the beach for recording animals in that capacity. Again, that would be a natural color camera.
Any bears or wolves for the?
Not that I'm aware of. The real problem is getting these animals in open environment. It works really well on the coastline where the animals are exposed, but if they're concealed in forest area, even with a really high-end thermal camera, the results we saw here, it's unlikely, but I wouldn't discount it.
Any other questions?
Like 12 people just pass up an opportunity to ask a question.
Yeah.
A quick wildlife question. So these guys are 3,000 to 4,000 feet in the summertime. What do they do in the wintertime? Where do they go?
Low elevations.
Like into the valleys? And
Is there a wildlife biologist there? Do we have an emergency wildlife biology question? I'll defer that to Kevin or Dennis or.
As Mark mentioned earlier, we've been doing studies on mountain goats in the Lynn Canal area for the last 3 years. And the mountain goats in this part of southeast Alaska primarily move down into steep, heavily forested environments, in some cases all the way down to sea level, but generally between 500 and 1,500 feet. In winter, generally they move down in mid-November, and then they'll move back up to higher elevations by late May, and have kids generally in late May, early June.
Thanks, Kevin.
Have you ever done any controlled studies with an animal on the ground, like at an airport or something, and did studies of the thermal qualities before you went to the field?
We didn't, but we plan to as part of our work. We were talking with Kevin about getting much closer to the animal on the ground, say on a snow patch, and trying it there. And just recently, we're looking at, they had the animals in their in their collars had a thermometer 2 to 3 inches from the neck of the animal recording ambient air temperature, which kind of helped a lot, and it is helping with our analysis of this study.
My question is, exactly how much data did you generate for the study?
With images, a couple hundred images flown at various altitudes.
Oh, like I mean, is that on the order of gigabytes or terabytes or?
For this, less than a gigabyte.
Okay, thanks.
Which is not typical for a larger area. Quite often imagery, cameras are getting so good that when we collect images, we're getting into hundreds or thousands of gigabytes or even terabytes of information. This is a relatively small project.
Yeah, this is a bit of a, I guess, historical question. I did hear that the mountain goats here were reintroduced and had almost died out. I'd like to verify if anybody knows whether that's true or not. And also, are there any records from, of course, the mountain goat was used for the chill cap blankets, and I don't know if there were any sort of records of how thick these animals were and what their range was prior to when they were reintroduced, and what wiped them out. Does anybody know the history?
Before passing that, my comment would be the biologists do monitor this because it is such a prevalent indicator species, and this is why they're studying it. But to answer your question more specifically, I'd defer to someone else. Kevin didn't realize he was going to be so lucky tonight. So thanks, Kevin. There you go.
So to the best of our knowledge, of course, mountain goats are native throughout the mainland part of southeast Alaska, and here locally in the Mount Juneau area, mountain goats were depleted, potentially due to overutilization by humans, potentially beginning as early as the mining days. And I think the last mountain goat was seen in that area sometime in the 70s, maybe. Early 80s, and so Doug just told me that in 1989 there was a small-scale sort of a reintroduction effort in that specific area of, I think, about 12 to 15 animals. 15 animals. No, this is right around Mount Juneau, Gold Creek, Perseverance, Mount Roberts area, but there was still goats in the surrounding mountains, all throughout like this area, and the Mendenhall Valley, Lemon Creek, Salmon Creek, and even over Mount Hawthorne, West Peak area. So there was goats around. It's just that the populations were really locally depleted in that area, and but there. So just in that one specific spot, there was goats that were reintroduced, and goats in that area have now, the populations have grown, and it was considered to be a successful reintroduction effort. In areas to the north of Berners Bay where we work, there's very limited human harvest in that area, and in fact, some of the areas there's never been any human harvest documented because they're very isolated areas there. And our aerial survey data over the last 3 years has indicated that there's probably between probably about 1 goat per square kilometer in alpine habitats during the summertime. So we estimate that between Berners Bay and north of the Katsahine River up near Haines, there's probably between 600 and 800 goats, which is probably pretty representative of what it was like, before there was any human activity in this area.
Any other questions? Okay, I think we'll call it a night. Thank you, Mark.
Hey, thank you, everybody, for coming out.